The big three kinematics equations. If an object is accelerating, then the formula v equals change in d over change in t gives us only the average velocity. We can also find average velocity using the formula v average equals v final plus v initial divided by 2. This is v average. Let's identify some variables. So v is final velocity, VO is initial velocity, A is acceleration, D is distance, and T is time. The first three are vectors, so they have a magnitude and a direction. Direction is either going to be positive or negative. And then the next two right here are scalar quantities, so they have no direction. The first uniform motion formula that you could use is V equals VO plus AT. Alright, so let's read this question and let's identify our variables. V equals VO equals A equals D equals and T equals. So from the question we see that VO speeds up to, that's the V final, 22 meters per second. V initial is 7 meters per second. A is we don't know. We don't have a distance. And T is 1.7 seconds. Now we're just going to plug these into this formula. V equals VO plus AT. Right? So now we're going to plug in these values. So let's plug in 22 equals 7 plus 1.7a. Then we bring the 7 over to the other side, so it becomes 22 minus 7 equals 1.7a. So 15 equals 1.7a. So then what we do is we divide both sides by 1.7, right? And we get A equals 8.8 meters per second squared, and it's east. Okay, how do we know it's east? Well, if we go back up, it's telling us that the car is traveling in the east direction. Alright? The next equation that could be used for uniform motion is D equals VOT plus 1/2 AT squared. Alright, so let's look at this question. A sprinter starts from rest and accelerates uniformly, travels 100 meters south in 9.69 seconds. What was his acceleration? Okay, let's define our variables. So since we start from rest, our V initial is 0, our distance is 100, and our T is 9.69 seconds. So we're going to plug that into this equation. D equals VOT plus 1/2 AT squared. Now, since V initial is 0, that means that 0 times time is just going to be 0. So we can erase that, and then we're left with D equals 1/2 AT squared. Alright, so then we just plug our info in here. 100 equals 1/2 A 9.69 squared. So then we solve for A, and A is 2.13 meters per second squared. And again, we have to include direction. So that direction is south, because it's a vector, and it's telling us that he's traveling south. Next equation that we could use during uniform motion is v squared equals VO squared plus 2AD. Alright, so let's read what the question says. A banana boat accelerates from 15 kilometers an hour to 2 meters per second squared. How far has it traveled when it reaches 30 kilometers an hour? Okay, so notice again that we have kilometers an hour, so we have to convert the units. So let's write our variables out. Okay, so we have to convert our kilometers an hour to meters per second, so we divide by 3.6 like we did from the intro unit. So it gives us 8.33 meters per second for our V final. Our V initial is 4.17 meters per second, and our acceleration is already in meters per second squared, so we don't need to convert it. Now we just plug it into this equation, and we solve for our distance here. Okay, so the equation is again V squared equals VO squared plus 2AD. So it's going to be 8.33 squared equals 4.17 squared plus 2 times 2 times D. Alright? So now what we need to do is we need to bring this over and divide by this number. So it becomes 8.33 squared minus 4.17 squared divided by 4, which equals 13 meters. So this is a distance, we don't need a direction, so this is just our final answer. There's no direction associated with it.